We have equation 23 as dou by dou y hsz plus 1 by j omega mu dou square by dou z square esx minus 1 by j omega mu dou square dou z dou x esz is equal to j omega epsilon esx. That is equation 23. And as I said earlier that the electric field and magnetic field components is proportional to the direction of propagation of wave. So I can write this Esx is proportional to exponential of minus gamma z. So Esx is equal to a constant into exponential minus gamma z, and I am taking the derivative with respect to z, so that here I can write dou by dou z Esx is equal to a into dou by dou z exponential of minus gamma z, which when differentiated I will get minus gamma a into exponential of minus gamma z. And you know this term a into exponential of minus gamma z is what? Es of x. So I repeat here, the variation of Esx, Es by Ez and Hsx, Hs by Hsz is proportional to the signal in plus z direction, that is exponential of minus gamma z. Based on this condition we are deriving at the relation equation 24, that is dou by dou z Esx is equal to minus gamma Es of x. Now I am going to take the double differential of equation 24. Finally I will get dou square by dou z square Esx is equal to gamma square a into exponential of minus gamma z, where you know that this term a into exponential of minus gamma z is equal to Esx. So finally my equation 25 is dou square dou z square Esx is equal to gamma square Esx, equation 25. Next what I am going to do is I am going to substitute equation 24 and 25 in equation 23. This is my equation 23. So in equation 23 we have two terms. One term is dou by dou z of Esx, another term is dou square by dou z square Esx. Instead of that those two terms we will substitute what? Minus gamma Esx and gamma square Esx. So finally equation 23 appears to be like this, that is dou by dou y hsz plus 1 by j omega mu gamma square Esx is equal to minus 1 by j omega mu dou by dou x into minus gamma square Essz is equal to j omega epsilon Esx. So I am simply substituting 24 and 25 in 23. Now I am rearranging the term. Finally I will get the above equation as 1 by j omega mu into gamma square plus omega square mu epsilon Esx is equal to minus gamma by j omega mu dou by dou x Essz minus dou by dou y Hsz. And this term gamma square plus omega square mu epsilon is taken as h square. And you know what is omega square by mu omega square mu epsilon, that we have already taken it as k square. So finally I can write h square is equal to gamma square plus k square. So this expression finally appears to be h square by j omega mu Esx is equal to minus gamma j omega mu dou Ez by dou x minus dou y dou Hz. Next I am dividing the terms by h square by j omega mu. Okay, so I will get Esx is equal to equation 26. Okay, similarly you can find the value for Esy, which is your equation 27, Hsx is equation 28 and Hsy is equation 29. So you can follow the same step which you followed to find out Esx, to find out Esy, Hsx and Hsy. Okay. So from this equation it is seen that there are different types of field pattern. Each of these field pattern is called a mode, because Esx it is a different pattern, Esy is a different pattern, Hsx is a different pattern and Hsy is a different pattern. So all these corresponds to 4 different modes. And as we discussed earlier, you can see earlier we discussed only two types of mode, that is TE mode and TM mode. There is one more mode, that is TEM mode, that is transverse electromagnetic mode. Here electric field and magnetic fields are transverse to the direction of wave propagation. That means EZ component and HZ component is 0 in transverse electromagnetic mode, and which is not supported by a rectangular waveguide. Okay, this TEM mode is not supported by rectangular waveguide, but you can see this TEM mode in parallel waveguide. Okay, and these two, TE mode, transverse electric mode, you know the electric field is transverse to the direction of propagation. That means ESZ is equal to 0 and HZ is not equal to 0, as we said earlier. And equation 26, 27, 28, 29 are the X and Y components of TE mode. So if you are asked to derive the X and Y components of TE mode, you can follow the same step as we followed to derive equation 26 and 27 to find out ESX and ESY. Okay, similarly TM mode, transverse magnetic field, magnetic mode, where HSZ is equal to 0. And one more mode is hybrid mode. Hybrid mode is often represented as HE mode. Neither E nor H is transverse to the direction of wave propagation. That means in hybrid mode, ESZ and HSZ will not be equal to 0. Will not be equal to 0. And as a note, you can note this, that is for TEM mode, the H parameter is equal to 0. Therefore, your propagation constant beta will be equal to your wave number k. But for TE, TM and HE mode, the propagation constant is not equal to your wave number. And that's all in this video. Thank you.